Alright, welcome to my Isaac Sim Core API course. In this video, let's learn about how to upload USD models and assigning physical properties to our objects in Isaac Sim. But before diving into our example, there's one thing we have to do. First, enter into our example code, and you can watch this USD folder. Click this. And yeah, here you can watch several USD models at there. The universal scene description, in short, USD, is a framework for interchange of 3D computer graphics data. So our Isaac Sim will read those files and show you through NVIDIA GPU's powerful rendering functions. But to do so, you must first copy them into our Omniverse nucleus. What is the nucleus? Nucleus is data storage for collaboration and deploy. And here, I already installed this nucleus navigator, which is GUI tools for nucleus. So let me give it a try. Click this launch button and let's enter into our project folder, which is localhost/projects/ load balance edu. If you don't have one, just click this like button and make this one. It's too easy. So yeah, in here, all you have to do is copy all those USDs and paste it into this location. All right, let's launch our code example now. From Isaac examples in load balance edu, select this example 2, hello asset, and click this load. Yeah, and if I click this play button or press this paste button, this NVIDIA black NVIDIA cube will fall down, but not for this lead hydrant. That's because this hydrant now it ignores the gravity. So we're gonna learn about first how to spawn our own USD models like this hydrant, and second, how to apply gravity in a simulation. Here's our code. The first function I'm gonna explain is setup underbar scene. Yeah, which is for model spawning and world setup and for model property setup. And here, add reference to stage function with the first parameter for USD file location and the second parameter for its relative path in our stage. We can spawn our USD models into our Isaac Sim. But generally, the US files are not specifically designed just for Isaac Sim in mind. So for instance, if I click our actual USD model, which is hydrant in here. Yes, look at this. This is the actual USD file of lead hydrant. But as you see in here, it's too large. And also we want to change its rotations and translations. So we might want to do some several adjustment for this model. How can you do so? In our code, you can modify the positions with set or add translate op function. And you can modify the angle with this function, add orient op, and also finally you can modify the scale with this add scale op function. Those functions require objects mesh, so you can get them through this USD geometry.mesh.get function. And next, USD object paths like this cube URL or hydrant path. Those kind of variances now they are using this URL format. How can I get this? For instance, from our nucleus navigator, let me show you. Yeah, let me say that if I want to get an exact location of this hydrant.usd file, then click this like button and click this copy URL button. And let me just paste it into our code editor. yeah, you can get that like this in this way. So, but for layer, yeah, this is kind of absolute pet just for your PC. So they can be changed in others' PCs or in your another PC. So sometimes Isaac users utilize Nucleus APIs for acquirability path, and this can be either by those you get URL root or get access root path. Now we are back. For this is our second example as hello asset. So now do you remember that this lead hydrant ignored gravity? So now it's time to give him a new property. You can do so with either SimGUI or Python code. I will demonstrate both of them. So for giving a collision of properties to this lead hydrant by GUI, I mean the GUI, click the object, and from this object's property, click this add button. And here, physics, let me give him a collider. So after this, let me move this black NVIDIA cube a little bit on the top of this lead hydrant. And if I click this play button, you can watch that we gave a collision property to our lead hydrant. Now next, let's pause our simulation. And for giving a rigid body property to our objects, right, GUI, click this object, and from property again, click add button, physics, and rigid body. Now let's play again. If you play this simulation again, both the hydrant and this lead cube, black cube will fall down because our hydrant is became a rigid body object. And then here, let me give you one more tip from this eye shade icon. And if you want to visualize those kind of visualize the collision properties of this specific object, click this eye shape button, and from show by type and physics and collider, if you check this let me say that if I check this none button, everything will be disappear. But if you want to watch the actual collision of objects, you can visualize that through this physics collider and select it. And if you click the object, you can watch the actual collider options of our object. But keep that in mind, this will make your simulation a little bit slow, especially if this object is too complex or too large, it'll make your simulation too slow. Keep that in mind. Now let's implement this by Python code. I had made this separate example for this. So from Isaac examples and load balance video, this one, example 3, hello property. And click slot button. Everything is same, but the thing is now you can watch that this lead hydrant, yeah, now it has some kind of properties like collision and collider and rigid body options. So let me show you how can we do through the Python code. All right, let's dive into the code. For you, I already highlighted the crucial code lines in here. So first, to assign rigid body properties to a specific object, you can use this function, usdphysics.rigidbodyAPI.apply. And next, in order to assign the collision properties required, you have to acquire object's geometry first. You can do so by this geometry prim function. And then you can assign actual collision property by set collision approximation. But in here, the thing is you need to be careful because this function is collision approximation. What does mean that approximation? So if I link this reference in here, let's dive into the lower and down and down. And here, yeah, like this image, if you want more accurate collision approximation, you can use convex decomposition, like the second one. or it doesn't matter, the collider doesn't matter, then you can just simplify the collision approximation, something like convex hull, or the bounding sphere, or bounding box. And for Lear, I have no idea why NVIDIA hadn't mentioned in here, but in our Isaac sim, we have more options. Let's click this, and in here, collider, we have more options, something like SDF mesh or triangular mesh. Yeah, this is not an official, but based on my experience, given that the model is designed by CAD softwares, I highly recommend to use this SDF mesh, which is the most accurate and precise. And also, this triangular mesh is not bad. And if I click, let me try and just change the approximation types. Yeah, as you see in here, depends on the situations and your preference. Choose the most preferable options for your project. Yeah. Okay, so today we learned about converting USD files into Isaac Sim objects, and also we learned about how to handle the objects with basic properties. For more useful and practical tutorials, don't forget to subscribe my channel and stay tuned. Thank you for watching.